So I hope my screen is visible. We'll get started with the first question itself, which is find the duplicate in an array of n integers. So this right here is the question. So we have an array which contains n plus 1 integers. So anyone wants to try solving this first? Like suggest any method to solve this if you all have solved this before? Put it in the chat. Map, okay, but there's one condition. You can solve it only using constant space. Cycle detection, okay. Yeah, that will work pretty much. Okay, so anyone who didn't understand the question, I can explain it better than the statement itself. If you didn't understand from the statement, it's a really simple question. You have an integer array, and this array contains n plus 1 integers from 1 to n, but one integer is duplicate. So what we can do is we can simply use the sum. Okay, so the sum of I'll just use a whiteboard over here. So what they have given us is they have given us they have given us an array, and this array contains some integers like 1, 7. So first thing they have given us is what's the size of this array? 1, 2, 3, 4, 5, 6, and 7. So this will contain integers from 1 to 7. But this is an array of size 7. So this will contain integers from 1 to 6, and one of the integers will be a duplicate. So in total, there'll be 7 integers, but 6 unique ones. So let the integers be something like 1, 5, 4, 6, 3, 2, and let's say the duplicate integers at the end. This is the 2. And let's say the duplicate integer is 4. So what we can do is basically find the sum of this whole array, and we know the sum of first 6 integers because they have said that n integers are common, right? So the sum of first n integers is n into n plus 1 by 2, and we can use a single for loop to find the sum of this array, and the difference will easily give us this integer. So we don't need even a cycle detection and all for this question. That'll be an overkill, I think. I don't know. Do you all think this method will work? Let's try it out. Okay, so is the coding thing visible? Is the coding screen visible? Can someone just confirm? Yes, okay. So let n be the length of this, size. I hope lead code lets me submit without logging in. Okay, let n be the size. Or instead of this, we could just use an O2. Okay, I think we'll be recording this either way, so you can just watch it whenever you're free. Oh gosh. So I'll just log in. Okay, so I just logged in. We'll try running the code. Okay, so it's working on this. Let's try submitting it. Okay, okay, so this thing won't work. Probably will have to use the cycle thing. Wait, there is only one duplicate number. So how can they give 222? Okay, so constraints is given. Okay, yeah, you're right. Okay, so we probably will have to use the cycle detection thing. So how the cycle detection thing works is, so in this array, let's say we go to 1. Okay, we go to position 1 and we find, let's say at position 1 there is 1. So we are safe. 1 has been detected once. So we'll say, let this be -1 over here. Next, we'll go to this position and we see 5 over here. So what we do is we go to position 5 minus 1, position 4. Sorry. So we see 1 over here. We go to position 1 minus 1. Why -1? Because all the integers are from 1 to n plus 1 and our array is from 0 to n minus 1. And in other words, all the integers are from 1 to n and our array is from 0 to n, 0 to n minus 1. So we just want to use like the number as an index. So you'll get a hang of this. This is a good concept. You'll get a hang of it when you like implement it in a question. So for example, like if we have 1 over here, right? So we go to index 1 minus 1, which is index 0. And we say let the value at this index be -1. Okay. Next, 5. So we go to index 5 minus 1, which is index 4. So 0, 1, 2, 3, and 4. And let's say we say let the value at this position be -3. Then we continue going to this. Let the value at this position, which is 4 minus. Sorry, let the value at 4 minus 1. So we are at this position now, right? So let the value at 4 minus 1, which is value at position 3, be negative. So 1, 0, 1, 2, 3. Let this be negative. And we keep repeating this. So as we go move along, we'll see that all these values finally become negative. And another thing is when we reach this position, we have to take the absolute value of this -1, because we don't know this might, like, this value might have already become negative. So we have to take the absolute value of this. And for example, the main catch in this thing is finally when we reach this 2 with this extra 2, which is a duplicate, we will see that we take the absolute of this 2, right? So we take the absolute of this 2 and all the other values in this thing are negative. So absolute of 2 is 2. We take 2 minus 1, which is 1. And the value at index 1 is already negative, which basically means we have already visited this place. So it's like keeping a visited array. So when you're doing like when you're studying graphs and trees, you'll have this thing called a visited array, which will basically help you from not going back to the same vertex again. So this is like implementing the visited array in the array itself. So there's another way. This is one method. There's another way for the cycles thing. So what you could do is, so this is one method. I'll show you a different method now. So method 2. So I'll take another array, take a different array for an example. Let's say we have 1 here, 6 here, 6 here. Let's say this time duplicate is 6. Okay, so we'll take their array, right? So 1, 2, 2. Two, 3, 4, 5. So this is an array of size 5. Okay, so what we can do is we can go to position 1. We start from position 0, I mean. So we start from position 0. We take the value of this. So this is 1. I mean, another thing is the values in this are from 1 to n, but our positions start from 0. So whenever you're taking a value at a position, you have to always subtract 1. So this value is taken, we think of this value as 0. I mean, it's 1. So we subtract 1 and think of it as 0. And then we go to position 0. So is position 0 containing a value this? Otherwise, yes, it is. Next, we go to this. Is position, so 1 second, okay. I think this method might get a bit confusing. So I'll just implement this one first, and then we'll talk about this. Okay, so we go through our array. So we first take the position, which is nothing but the value at that index -1. So absolute value, because it can already be negative. So absolute value of nums of I -1. So this is a position, and we basically have to check if this position contains a negative value. If it does, we have found our answer. We can just break. So if else, we make the value at this negative. In other words, mark it visited. So if it is already visited, that means we have already found our answer, which is pos. So if position is visited, that means it is a repeat. So we have found our position and we can just return it. Else we mark it as visited. So else it is equal to So this is just because every function needs to have a return type. I mean, if a return type is mentioned, you need to return something at the end, but it won't reach to this point because we're already returning something over here, and it's guaranteed, it's given in the question, right? So this thing will always be satisfied throughout our question. Oh, so we have to return pos plus one. Okay, so that worked. So there's another method for the cycles thing. We'll discuss that. So I'll take something like 2, 2, 6. Why take 6? Take 3, 4, 1, 2, 1, something like this. Um, okay, no, so this doesn't satisfy the norm, right? So 2, now it's better. So one integer is repeating, the rest of them are just ones. So what can we do in this case? So let's say we start at position 2, position 0, I mean index 0. We see a 2, right? So we go to position 2 minus 1, which is position. At position 1, we see another 2. So that means may here itself have found that it's a duplicate. So we can just return. But let's say here there wasn't a 2. Let's say there was a 3 here. And 5 here. Okay. Let's say there was a 2 here. Something like this. Is this valid, first of all? Yeah, this is valid. So we start at position 0 and we take, let's say, 2. So I mean 2 represents, we see 2 as 1 because we always subtract 1. So we go to position 1. Position 1 has 3. Next we go to position 3. I mean we go to position 2, 3 minus 1, 5. So we keep repeating this. And finally 1 takes us back to position 0. And if position 0, oh, another thing we have to do is swap. Okay. For example, let's say we have 2 here, right? So when we go from 2 to position 3, we have to swap these two values so that 2 lands in its perfect place. Next, 3 leads us to this value. So we swap these two. So 3 lands in its perfect place if this was a sorted permutation that way. And 5 lands over here. Next, we go to position 4. And again, make the swap. So 5 comes over here. And 1 comes over here. And finally, we see that 1 leads to position 0 itself. So this cycle is complete. Then we move on to the next index, which is free. I mean, we can move to 3 itself. We can move to this index itself, and we'll see this index has now it has 2, and 2 leads to position 1, and position 1 already has 2. So we'll keep moving to the next index. This index has 3, 3 leads to position 2, and position 2 already has 3. So that's fine. Next we lead to this index 2. So 2 leads us to position 1, which is always subtract 1. Position 1 already has a 2. That means we have found a duplicate and we can just exit. Okay. So you can try implementing this method out yourself. There's another question which is a similar thing. It's called permutation cycles. I think I sent it a while ago on the same group. You can try that out too. So let's go to the next one. Sort an array of 2s and 1s and 0s without using extra space. Okay. Given an array nums with n objects colored red, white, and blue, sort them in place so that objects of the same color are adjacent in the order red, white, and blue, which is red is 0, this is 1 and 2. So it's like the same question, just framed differently. Without using sort function and O1 constant space. Okay, so first thing is, can we solve this question in ON time? I mean, it's a sort question, but can we still solve it in ON time? Without, I mean, you can use like, okay, so can we solve this in ON time? Or can anyone say how we can solve this? It's a really simple question like this. I think you can just skip this question otherwise. Anyone knows how to solve this? Yeah, use 3 variables to store frequency of 0, 1, and 2. 3 variables is still O and O of 1 space. So that's counted. And once you have stored the frequencies, you can basically just put all the zeros at the start, put all the ones after that, and put all the twos at the end. So that's a really simple question. This code will take hardly any time. Oh, so we have an initialize this as 0. Okay, that's a really easy question. Let's move on. So I had discussed cadenes last time. Missing numbers. Given an array from 1 to n, find one number which is missing. Oh, given an array from 0 to n, find one number which is missing. Okay. So this we can do with the sum thing. This was also another easy question. So I hope everyone understood this question. Okay, this is a good question, I'd say. Merge sorted arrays. Oh wait, not this, the next one. Okay. So anyone knows how to solve this? What do you mean by the two-pass algorithm? Oh, you mean like a counting sort? Okay. So what about this one? Merge sorted arrays. Do you all know how to solve this? I mean, it's really easy. I mean, y'all can unmute yourselves and talk since there are just two of y'all. Okay, so I'll go ahead and solve it then. So the question says we have two arrays, nums1 and nums2. Nums1 has some elements and nums2 has some other elements, and we have to just, and both of these arrays are already sorted. Now we have to just merge them together in such a way such that the final array is also sorted. Now, another thing they have given us is, one second, I'll just clear this. Okay. So they have given us two arrays. So this is one array. This is another array. Okay, so I'll try to keep the sizes different. So what is the size of this? 1, 2, 3, 4, 5, 6, and 7. Size of this is 7, and size of this is 1, 6. Now both of these are sorted. So let's say these contain elements like 2, 12, 100, 101, 105, 200 maybe, and let's say some huge number, 1000. This also contains some sorted elements. Let's say 3, 4, 5, 6, 13, 14. Now individually both of them are sorted, and you must be, when you saw this question first, you must be like, why can't I just put one array after another since both of them are sorted? It's probably because they interleave. Like for example, when you put them one after another, you'll get something like 12, and then 3 will come, and 3 should come over here between these two. So your task is to merge them into a single array. So huge array. So merge this and this, and finally you should get this array, where this array is something like, 2, 3, 4, 5, 6, 12, and you get the idea. This is what it should be like finally. Now this would be a really simple task if, first of all, if you have been given this question in a competitive coding or like in a online round for a company, what you can basically do is just create a temporary array, allocate all the elements from the first array to it, allocate all the elements, and just sort this temporary array. That will happen in n log n time. Really easy thing, nothing to do about, nothing to use a brains on. So that will be n log n. Let's say n log n clocks out. You want to use an O of n algorithm. What you can do is interleave them. So we'll keep a 2-pointer method for this. Yeah, we can compare the start of both arrays. Perfect. So keep 2 pointers. So 1 pointer points to the start of first array, 1 pointer points to the start of second array. So among these two, see which is minimum. So in this case, 2 is minimum. So we'll put 2 over here. And let's say there's a third pointer which points to our temporary array. 2 is minimum. So we put 2 over here and we increment this pointer to this position. Now the pointer in our first array points to the first position, position 2, index 1. While the pointer in our second array still points to index 0 or position 1. Now we have to compare 12 and 3. So we see that 3 is smaller. So we increment this pointer to the next thing and we put 3 over here. So in this case, I've already put some values. So I'll just fast forward this a bit. Let's say our pointer reaches someplace over here. So this basically points to a vacant place. So right now I had filled 3, but initially this array will be empty, right? So let's say this pointer reaches someplace over here, and basically this pointer will be at this position. We have already taken care of all of these before, let's say, and this pointer will be at this position. Okay, so now what we have to do is compare 13 and 100. So 13 is smaller, put 13 over here, increment this to the next thing. And 14 is smaller, put 14 over here. And we see that this has reached the end. Okay, so once we see that one of the pointers has reached the end, we can just put the entire list of this. Use a while loop and put this entire list over here, and we are done. Okay, So this is really simple. And this is one of the basics for merge sort. If you have heard of merge sort, if you want to implement merge sort, this is the basic thing that you have to do. Now, this is a simple thing, but here the challenge is number of elements are m and n, okay? So so I'm assuming m and n won't be like more than 10 to the power 5, since we need a linear complexity, right? So you may assume that nums1 has enough space to hold additional elements. So now our challenge is nums1. Our challenge is basically we can't use a temporary array. Okay, so basically nums1 is now huge, such that at the start all the elements are there, which we first saw. Like let's say nums1 has 2. So let's say nums1 size m, which is denoted by m, is, let's say 4. We'll take 4, small number, easy to deal with. N is equal to 3. And let's say the size of nums2, the second array, is 3. So this contains just 3 elements. Okay, so let's say 5, 7, and 9. And let's say nums1 contains 4 elements, right? So 1, 2, 3, and 4. So we don't need this. One, two, let's say 10, 11. That's it. Now what they have told us is nums1 contains some extra space at the end, which is this, some extra space. Here there can be garbage, 0, whatever, but we don't have to access it. We can't. It's not initialized. We have to initialize. I mean, it's only initialized. I mean, it's only defined. It's not initialized. So we have to fill this place up such that the final array is sorted. So how can we do this? Now that makes it a bit more challenging since we can't use a temporary variable. So can anyone try this out? It's a good question, I'll say. And this will probably come in an interview, on-site interview or phone interview probably. This won't be asked like, coding interview. I mean, in an online round. In an online round, it's easy. You can just sort it and go ahead, finish it up. Could anyone try in the chat, or you could probably unmute yourself and see how you're going to solve this. Initialize second array to the uninitialized space of the first array. You mean like take all of this and push it directly over here. So this basically will be of this extra space will be of size 3. That's what is given in the question. The entire array is of size m plus n. Size of initialized is m, so size of uninitialized will be n, and n is 3 in this case. So you're saying we push 5, 7, and 9 over here. Okay. What do we do after that? Then we compare 2 and 5. Okay. And we see, okay. Yeah, that's a good method. Okay. Yeah, perfect. We can do this too. So what he's saying is put 5 over here, put 7 over here, and put 9 over here. So then what we do is we compare, we put a pointer at position 0 and pointer at position m. So then we compare these two values. If the larger one is at the first pointer, then we have to swap. I mean, let's say if there's a larger value like 12 over here and this is 7, in that case we swap these two. Else we increment our pointer to 3, because we have to make sure that the smallest value comes at the start and these all are solid, and these all are sorted. Since comparing these two, this is the smallest, that means this will be the smallest comparing to all of these, because these all are already sorted, right? So next we move our pointer to this position, position 3, and we check, are these two, which is the smaller one? So 3 is already smaller one and 3 is already in the start. So we can just say, okay, go to the next point, 10 and 7. So in this case, we compare. 10 is larger than 7. So in that case, we must make a swap. So we just swap 10 and 7. So 7 comes over here and 10 comes over here. Okay, so now we have run into another problem. This array isn't sorted anymore. So how are we going to tackle that?
Am I
So
audible?
yeah,
Hello.
yeah.
Yeah. So I was saying that so two, you should swap 10 and 5, not 10 and 7.
10 and 5.
Yeah.
Okay, yeah, sorry. Oh, my mistake. So yeah, I mean, okay. Uh, Go to 10. I didn't see 5. 10 and 5 we swap. So 5 comes over here and 10 comes over here. But now this array isn't sorted, right? So what are you going to do about it?
No, let's like then 7, 9 is sorted, right?
Yeah, okay.
So then we compare 11 and 7.
11 and 7, okay.
Then we swap.
Okay. Okay, yeah. So, but still there'll be this redundant 10 over here. So what are you going to do about that?
Then 10 and 11 we'll see. And 11. Oh, yeah, yeah, yeah. I get it. I get it.
So if you like try to code it out, it'll be like a really complicated logic. You'll have to use like a lot of edge cases and stuff.
Yeah. Right.
Okay. So what else can we do? So first thing that we have to make the most out of is we have this extra space. So we have to do something which utilizes this extra space to its perfectness in the start itself. So that's a leverage because we can't create more space, right? So this extra space has to be used to its perfection. So what we can basically do is start a pointer at this position. Okay. So what we normally do is we fill from the start, right? How about we start filling from the end? So let's say for filling from the end, this is n equals 3, right? So this basically has 3 slots. So let's say this has 3 slots and this has 4 slots. So we basically have to fill from the end position. So what we do is keep a pointer at position m plus n minus 1, which is basically the last position of the first array, which is of size m plus n. Next, what we do is we keep a pointer at this position, the last position which contains a valid value in the first array, and the last position which contains a valid value in the second array, which is 9 and 11. Next, we compare these two. Which is larger? 11 is larger, so we place 11 over here. We'll decrement this pointer. So next we compare 10 and 9, and it's like the same method as before, but now we're going from the reverse of the array. So now we're filling in the array from behind. So in other words, if they had given you space in the start, you could have used this method. You could have just directly compared for the, I mean, you could have directly filled from the start, but they have given you space at the end. So you have to start filling from the end. In a temporary, you fill from the start, right? So in this case, you just start filling from the end and that will work out perfectly. So now we have 10 and 9. So what we can do is place 9 over here since 9 is smaller and decrement this. So 9 is taken care of, 11 is taken care of. Now we have 10 and 7. So 7 is smaller, place 7 over here. 7 is taken care of. Now we see 11 is over here, but 11 is already taken care of. So this is nothing but a null position. This is nothing but an invalid position. So you can use this. So now we put a pointer at this position and we see 10 and 5. Sorry, not which is smaller. What am I doing? Which is larger. So 9 and 10, we have to put the larger one, which is 10. So you move to this point. Next, 3 and 9, which is larger? 9 is taken care of. 3 and 7, which is larger. So when you're comparing 3 and 7, you reach this value 11, but we see 11 is already taken care of and 10 is also already taken care of. So in other words, while this pointer is greater than this pointer, we can continue with this method. And once they are equal, that basically means that this list doesn't have any more values left. When will they be equal? These 2 points. Why is this? Because let's say these 2 pointers, let's say they're equal. Okay, these 2 pointers, let's say they match. That basically means the smart space has been filled. Okay, so let's take this. Let's take the position of the first pointer, the pointer which starts from position M. Let's take that position as X. Then in that case, the pointer which starts from the end will also be at a position X. But you see this pointer, the pointer which starts from the end has traveled a distance of n plus m minus 1 minus x. And the position that pointer at the start, still, that means we still have values left over here. So the values left due to this will be m minus, sorry, the values covered over here will be m minus x. And the values covered over here will be n plus m minus x. Sorry, n plus m plus 1 minus x. And the difference of both of them will be n minus 1, which is the pointer position, which is basically the distance covered by this pointer, right? This pointer starts as n minus 1 and ends at 0. So the distance covered by this pointer is n minus 1. In other words, we see that this pointer has already reached 0. So in other words, if the moment these both pointers coincide, we can say that we are done sorting. So let's try implementing this. Okay, so we start from the end, right? So what we know is nums1 has size n plus m minus 1. Okay, so for then I is equal to, so we are starting from the end, right? So this denotes our first pointer. Now what about a second and third pointer? Where will they start? So second pointer, so in other words, pointer of the first array, we'll call that as nums1 pointer pt. So nums1 pt starts at position nums1 pt, and I'll just make this a bit bigger. Okay, so I think that's the maximum. So nums1 pt starts at the end, right? End of the first array, which is m, and nums2 pointer starts at the end of the second array, which is n. Wait, it starts at m minus 1 because arrays are defined from 0 to m minus 1 and n minus 1 similarly. So when will they stop? They will stop when one pointer becomes less than or equal to the first pointer in the array nums. So while this is, so while this pointer is greater than this pointer, is ahead of this pointer, we can continue. And the moment they become equal or the moment they cross, we have to terminate. We have to terminate the moment they become equal itself. So we can't let them cross. Okay, so nums at I will be equal to the, we'll call it some, okay, so let's define maxi. So maxi will hold the maximum value of both of them. So let's say initially it holds the value at pointer 1. Okay, no wait. So basically if the value at pointer 1, so nums 1 at the value at pointer 1 is greater than the value at pointer 2, in that case the value should hold the greater value, right? So let's not, else it will hold the smaller value. Okay, so if the value of the at the first pointer is greater, we assign the value at the first pointer to the end and we decrement the first pointer. Decrementing is really important. You can't forget that. End up picking a mess otherwise. And why do we decrement and not increment here? It's probably because we are starting from the end, obviously. Okay. So finally, what do we have to do? We have to return they don't want us to return anything. Okay, so they probably don't want us to return anything. Let's try running it. Oh, sorry, nums one at high. Seems to work fine. Let's try it out. Okay. This case failed. So 0, 0, 1, 1. What does this mean? Yeah. Okay, NNM. How is this even a valid case? Oh, submissions. How is this a valid case? Okay, so another thing is you have to make sure that at the start, so for your interviews especially, keep this in mind. At the start, make sure that both the values m are greater than 0. I mean, the size of the arrays can't be lesser than 0, right? And size of the arrays, so mostly in competitive coding, like the things will be given to you, but in interviews, it's best not to use it. Okay, why is it bugging? So if m is greater than 0, you can continue. I mean, if m is equal to 0 or n is equal to 0, in that case the answer will be okay. So we have to take a bunch of cases. So if m is equal to 0, then in that case let's check if n is equal to 0. So if both of them are 0, then just return back. You don't need to do anything. Else if n is not equal to 0, n has some value but m doesn't have a value, then push that value to m. No, wait, 1 second. I honestly didn't understand this case. If anyone understood, can you all explain in the chat? How can 0, 0, 1 and 1? I mean, the first length has to be equal to the sum of both, right? So how can it be 0? I think it's supposed to be this way. Oh, okay. So they are two different cases, if I'm not wrong. Okay, okay. Gotcha. Okay. So first case, if both of them are 0, return, can't do anything. Else if n is equal to 0, oh, okay, okay. So m is the size of the array without the zeros at the end. Okay. So this basically is an empty array. So if m is equal to 0 and n is equal to 0, we can't do anything. And I think that was a valid case. I still don't understand what the answers should be. Okay. So what should I do? Should I just remove the trailing zeros? Okay. So if m is equal to 0, then in that case return nums2. Okay. Oh wait. Uh, nope. Something is still going wrong. So I think we'll come back to this. Solve the next one first. Given a collection of intervals, merge all the overlapping intervals. So this is also a really common question. Okay, so 1 second. If m is equal to 0, I think I was missing out this return. Okay, there we go. Okay, runtime error. I think the answer should be 2-1 in this case, 1-2 in this case. But why is it not happening? Oh, so another thing we haven't mentioned over here is the uh, nums at 0.1 greater than 0. Oops. Okay, there you go. Okay, so this was to check the overflows, and we had missed that. What if we now don't use this, since we already used the check for overflows thing, but it's still submit? Okay. So the only thing we missed was the checking for overflows. So basically, since we are doing num point one minus minus, num point can go negative. So we have to make sure that num point is negative, because if num point goes negative, this whole thing won't make sense. Okay, similarly, num point two has to be greater than zero. And that's basically it. Okay. So given a collection of intervals, merge all the overlapping intervals. For example, this. So I'll just take this example itself and explain it if you haven't understood. Okay, for some problem. So I think we'll just finish this quickly and we'll go on to the foursome problem. Okay. So basically what you see over here is there's an interval from 1 to 3. There's an interval from 2 to 6, 8 to 9, and 10 to 15, and 15 to 18. So when you check these two intervals together, you see that these two intervals intersect because 2 lies over here and 3 lies between this. So when you combine both of them, their combined will be 1 to 6. Now, when you combine these two, it'll form 1 to 6, and 1 to 6 and 8 to 10 don't intersect. 8 to 10 and 15 to 18 don't intersect. So we're perfectly done the moment we check that thing. So the way to solve this is think of the intervals as lines. So let these three be three intervals. We'll give each line a start, S, and an end. And basically sort all the starts together and start together with the end. So in this case, some sorted thing will be like start, and then another start comes, another start comes. A start, then another start, then an end comes, then another start comes, then another end comes, and then the finally last end comes. Next, we'll give each start a value of 1 and an end a value of -1. This is similar to what we call as the Euler tour. We'll study that in graphs. So Euler tour is also the same thing. So now what we basically have to do is the moment the sum becomes 0, that basically means that we have reached something like this. So this whole thing is one interval. So the moment the sum becomes 0, it's one interval. So if there's some other unintersecting interval, something like this, start and end, it will have its start after the end. Okay, so we start from here. So is the sum is 1, sum is 2, sum is 1 back, sum is 2 now, sum is 1 back, and sum reached 0. So the moment sum reached 0, that means we have reached one interval. Next we start from here, sum is 1 and sum is 0, so we have reached another interval. So if there's finally some one more interval like this, then in that case there'll be between these starts and these end, there'll be another start and another end. There'll be another start and another end. So again, the sum is 1, sum becomes 2, sum becomes 1, and sum becomes 0. So this whole thing will be one interval. And let's say there's finally some huge line like this, such that its start is right at the start of all of them and the end is right at the end. In other words, the start is like this and the end is like this. In this case, what happens is here we start with 1 and then we reach, this whole thing will be an interval, and you can check it with this also. Here now the sum won't be 0. Whenever it ends, it will be 1 because we have added another start at the start, right? So all the sums of each of them will get incremented by 1. All of these will also get incremented by 1, and finally it will become 0 at this point. So all we have to basically do is label it as like transform it from the arrays that they are given in to the start and sequence to this 101 minus 1 thing, and finally all we need is what? The prefix sums, right? So what is this? This is nothing but prefix sums. And the moment the prefix sums hit 0, we can say that that's an interval. Now that can get a bit tricky. So we'll have to, so we'll just code this one out. And after this, I'll do the for something. Okay, so we are given intervals. So let's find out the number of intervals. Before that, we'll create a vector which will store this 1 and minus 1. And I'll call it the tour, inspired of the Euler tour. Next thing is how many of them will be there. So each uh, each point in this interval has two coordinates, right? Start and end. And how many coordinates are there? That is given by the size of this interval. So intervals dot size will give me the number of coordinates in this thing. After this question, I probably won't code any of the questions that I'll just explain how they are solved. And if you need, you can ask me for the code and I'll probably give it to you. Or probably put it on the group if you need it. So the store will be a vector of size. It's another thing is to good. Another good thing is to initialize all the things right at the start. So if we encounter a closing bracket, so if intervals, oh, okay, wait. So what we'll do is we'll store the start of the interval as +1 and the end of the interval as -1, right? So tour at I, sorry, tour at 2i will be the start. And tour at +1 will be the end. So tour of 2i will store +1 and tour of 2i will store -1. Now with this approach, we're going to run into an error, but till then we'll just follow this approach, okay? Now another thing is, let's say, the thing we're missing out is all these intervals can be given in any random order. So we'll have to sort them. Okay, so we can't just store them as 1 and -1 because in that case, when we sort them, all the end parts will come before the starts and it won't make sense anymore. So we'll have to store them such that they get stored with their coordinate, which is 1, or it could be 6, or it could be 8, whichever, and whether it's a start or whether it's an end. Okay, so we'll store them as pairs. So we'll store them as pairs, as a vector of pairs of size 2n. 2n, why? Because there are 2n elements. There are n intervals and each interval contains 2 elements. Okay, so how will we store this as a pair? So first thing, we'll have to store it by the start index. So the start index is intervals at I of 0. So this denotes the start, and 1 signifies, this is basically a value, okay, this is an integer value, so it can't denote a start and an end, and 1 basically says that it's a start. And similarly for this with a -1. So 0 basically means it's the starting of this thing. Interval at 0 is this or this, and interval at 1 is this, the second thing. Okay. Next thing what we need is we need to sort these. So sort. So we'll just use the stl sort function, and give the start coordinate. Give the end coordinate. Now these are sorted. Now all we need to do is traverse to this array. So for I is equal to 0, tell I is less than 2n. I will maintain a sum. So sum plus equals 2 out of I, and the moment sum hits 0, if sum equal to 0, that basically means we have found a closed interval. Now what do we do once we have found a closed interval? We have to store it in a vector of vectors and return it, right? So we'll create a vector of vectors. We'll call it interval merged. And finally we have to return this. So if the sum is equal to 0, this dot push back the interval. But what's the interval is the question now, because we don't know. We just know the sum, right? We're just keeping a track of the sum. So how can we find the interval? First thing is, where did the sum become 0? So first thing, where did the sum become 0? That will be given by I. So if sum is equal to 0, that means it became 0 at this point, 2 of I. So that means I is the index in 2, which will tell us the end coordinate, because end is always a -1, right? So it will always become 0 on a -1. It won't ever go negative. Okay, so this is an important point. The sum will never go negative. Why? Because you can't have an end before a start. If you have an end before a start, doesn't make sense. But in that case, if it does, if it ever did make sense, that the value would be negative, but it doesn't. So vectors are pushed back. So we have to push a 2D vector. So we can just create a vector using these. So inside this intervals dot merge, we have to push back a vector, and we are creating a vector using this. And the vector has 2 coordinates: the start, comma, end. So again, the end will be denoted by this I and 2. So 2 of I. So if you see in this, 2 of I will hold like 1, comma, 1, 3, comma, -1. I mean, they'll be sorted after this, but basically if these are the things, it'll be like this. One second, I'll just use a text. Okay, so 2 of I will hold pairs like this, 1, comma, 1. If this is an interval, if this thing 1, 3 thing is an interval, 1, comma, sorry, 3, comma, -1. then again 2 comma 1, then again 8 comma 1. I mean, before this there'll be 6 comma minus 1, then there'll be 10 comma 1, and so on and so forth. But you get the idea. Okay, so I mean there'll be more intervals after this, but these will be somewhat like our intervals in 2 hours. So it will be something like 1 comma 1, which will basically say that at point 1 it's a start because there's 1 over here. So again, point 3 there's a minus 1, so it's an end. Point 2 there's a 1, that means it's a start. Point 6 minus 1, that means it's an end. And when we sort all of these, right, so between 3 and 6 this 2 will get swapped over here. So in other words, this 2, when we sort, this 2 will come over here and this will go over here, and these won't get affected pretty much because they're already sorted. So what we basically need is 2 out of I of dot first. Now again, you might get confused with the notation. Why am I using first over here? Why am I using what's that? Why am I using 0 over here? Why am I using first over here? It's simple. It's simply because here it's a vector of vectors, while here tour is defined as a vector of pairs, and pairs are referenced to as first and second. So first refers to the first element of the pair. In our case, that would be the value index, and the second element would be whether it's a closing bracket or a starting bracket, denoted by -1 or +1, +1 or -1. So now we have found a ending bracket. So what about the starting bracket? How can we find that? So we can't find that directly. So we have to keep a track of it as we are moving forward. So what we'll do for that purpose is keep a track of it. Int start bracket. Okay. By default, we'll initialize the start bracket as 0. So if okay, so we'll start from 1 and we'll initialize the start bracket as, we'll initialize the sum as 1 because the first will be an opening bracket and the start bracket as tour of I dot first, and sum will be that's second. Okay, so now the moment sum reaches 0, we can store this. Oh, sorry. What did we have? We had the start bracket, right? So this, now we are storing it as a vector. Again, here the curly braces signify a vector. It could also signify a pair, but it gets sorted accordingly because intervals merged has been defined to be a vector of vectors. So this has to be a vector. So it will get typecasted to a vector. Okay. So if sum is equal to 0, intervals dot push back this interval. This is an interval, start and end. And now what we have to do is we have to reset. We have to reset the start bracket, right? Because we've already ended. So now we have to reset. So what do? We'll say, let's say next time when we say if sum is equal to 0 itself when we start, then in that case let start bracket be equal to, okay, so we won't need this line then. We won't need this line. So let's start bracket be equal to tour of I. The first, and sum be equal to so we can just start with 0 and start bracket not defined. Perfect. And this should work. Okay, so it doesn't. Let's see why. So let's just print our something first, so you get a better understanding of what's happening. One minus one, one minus one, one minus one, one minus one. So this is basically what? This is our tour array. So tour one basically signifies a start bracket and then an end, and then a start and then an end. Okay, so this start. But so the thing is, I think tour hasn't gotten sorted yet. That's the thing causing the problem. So if we print tour of I dot second, comma, so 1 comma 1, 1 comma 3. So if you see, this hasn't gotten sorted yet. So that's the thing causing the problem. Okay, so we have sorted intervals, not tour. Okay. And I'll just print this thing now to show you how it looks like after sorting. Okay. So it looks like 1 comma 1. 1 basically means this one, and the second one means it's a start bracket. Next comes 2, but 2 is an end bracket. So, but 2 is again a start bracket. So again we get a 1. Next we get 3, which is a minus 1 because it's an end bracket. 6 minus 1 end bracket, and let's say some arbitrary thing, 15 with a 1 basically means 15 is a start bracket. And the output is also correct. But over here, we are going to run into a problem. So I'll submit it, and I don't think so it will get submitted. Come back and I'll explain the problem. I'll just hash this out. We probably need it again. See, this is the problem. If a thing starts and ends with the same interval, for example, so in this case, what we had said was these are all distinct. But what if there's an interval like this and another interval that starts at the same point? Okay, so this ends at this point. Let's say there's another interval which starts at the same point and continues. So we give this start, end, start, end. So if two of them start at the same point, it's if two of them end or start at the same point. In other words, two intervals have a common point, have just one common point. In that case, what happens is our final thing is created like this start, because let's say this is 3 and it's a start, so it will be 3 comma 1. Let's say this end is a 4, or let's say a 5 comma minus 1. This start is a 5 again, since it's at the same point, so 5 comma 1 since it's a start. and this end is, let's say, maybe 9 comma minus 1. Technically, we should merge these intervals and consider them as one single interval. But is that happening? Let's see. When we sort this, what happens is the sorted interval we get is 1, 3, comma 1. Next we get as now 5, comma 1 and 5, comma minus 1. How will you sort this? First digit is the same. So when sorting, the second digit is given priority, right? So in this case, 5, comma minus 1 is there. So minus 1 is given priority. So 5, comma minus 1 comes first, and then comes 5, comma 1. And then 9, comma minus 1. I'm not going to write down. Okay. So in other words, if you see over here, end comes before start. But we have to give start the priority. So how can we give start the priority in this case? Well, the only way we can give start the priority is when we are sorting, we can say to the sort function, you sort in ascending order for the first thing and then descending order for the second thing. So for that, we use something called as a lambda function, and you pass it as a parameter, but that thing can get a bit complicated. So an easier way is to just flip their signs. So if this becomes a positive and this becomes a negative, and if this also becomes a negative, so all the positives will become negative and all the negatives will become positives. Okay, so in that case, this will be given priority. So this will come over here and this will go over here. In other words, the end thing will be given lesser priority than the start thing. Why? Because now start is minus 1. Okay, so start is denoted by minus 1. Start will come before end in case if it's equal. Okay, so this is a trick that you can use for sorting something in reverse. Just multiply it by minus 1. In that case, it will get sorted by reverse. And when you want the values, just multiply them by minus 1 again to get back the original values. But this way they'll just get sorted in negative order. So let's try implementing this into our code. Okay, so we'll give this minus 1 and this 1. So now another thing over here is it honestly won't matter because 1 minus 1 or minus 1, sorry, 1 minus 1, 1 plus minus 1 or minus 1 plus 1. Either of them will touch 0, and we don't have to check if it's positive or anything. We just need only condition that we need for an interval is sum is equal to 0. So either way it will be 0, whether minus 1 comes first or sum, whether plus 1 comes second or minus 1 comes second. But the only thing is start won't be given priority. Okay, so in this case, if we try running and we keep the test case as, let's say 1, 2, 3, 3, 8, okay, something like this. Run code. And you see it's getting merged perfectly. So the only thing, sometimes what happens is you want to bring it back to the positive realm from the negative realm. And I'll just submit this and I'll tell you how you all can do it with the lambda function method also. So this was a success. So for the lambda function, comma, in this case, let's say I decide to give it 1 minus 1. Lambda functions are defined like this: square, round, and curly. Okay, that's how they're defined as. And inside these curly braces is what the function takes, or whatever happens to the function happens in these curly braces. Round braces are for passing parameters. Okay, so what parameters are we going to pass? Tour has what? Pairs, right? So whenever we are sorting tour, we are going to compare these pairs. So whenever we are passing, also the two parameters should be pairs. So pair A and let's say pair B. And what we basically want to say is, yeah, so the lambda function is a comparator. Yeah, pretty much. So pair A and pair B. So what we want to say is if A dot first, because pairs again take first and second, keep that in mind. So if A dot first is not equal to A dot second, in other words, if both the things are different, return A dot first greater than a dot second. This basically means you have to return a bool value. So over here also we have to mention the return type. So we mention it like this with an arrow, and then we type the return type. And I want you, the syntax for this is really simple. It's square brackets, then round brackets, and then curly. And between the round brackets and the curly braces, you get the return type, something like this. Okay. And your full function comes inside the curly braces, and your function for and your parameters that you're going to pass to it come inside the round braces. In this case, we are passing two pairs. Okay, so if a dot first is not equal to a dot second, return a dot first is greater than a dot second. Okay, so what this thing will do is it will receive, let's say, a dot first as maybe 10 and a dot second as 5. If 10 is greater than 5, it will return true. So, okay, so I think we have to do it the other way around. Okay. Again, greater than or greater than equal to you can use, because if equal to it doesn't matter. So else, if both are equal, so which is just an else. If both are equal, and in that case, I want to compare on the second thing, right? So if both are equal, return a dot second greater than a dot greater than, sorry, a dot first greater than b dot first, not a dot second. Okay, so if you compare the first things of both, my mistake, a dot second greater than b dot second. Now another thing is, if you get confused with how to choose this sign, whether to choose it less than, greater than, how did I choose it? Just use trial and error. Okay, it will either be one of them. So just try both out and you'll understand. Okay, so in this case, it has gotten sorted perfectly. Oh no, it hasn't. Okay. Mm-hmm. Oh, if a dot first is not equal to b dot first. Okay, and so my mistake. Okay, so there you go. Again, if you get confused with how to choose these, use trial and error. It will be either one of them. Okay, so try both out. Whichever you get correct, use that. Don't get confused with this. It's a really simple thing. You can use it if you want to. Otherwise, you can use the negative sign over here. Both will work. Doesn't matter. Okay, so there you go. This also works. Next question, we'll do the four sum question. So, okay, I'll just quickly go through the two sum thing as well. To something and for some problem. Sorry for login again. Okay, so given an array of integers and an integer target, return the indices of two numbers such that they add up to the target. Okay, so what we have to do is basically, if we're given a target and we're given some integers, so if 2, and we have to just check it. So if 2 and 7 they add up to 9, so we found our answer 0 and 1. 2 and 11 they don't, 2 and 15 they don't, 7 and 11 they don't, 7 and 15 they don't, 11 and 15 they don't. Okay, so what we basically can do in this case is brute force solution is just check all the pairs and square thing. Otherwise we can use a map and the map will store the complement. So what we call as the complement is complement of 2 is 7 because 9 minus 2. So if 7 exists, we're good to go. We can just print it. Another thing is you have to make sure you don't calculate the same pair twice. That's another case that you have to take care of. In this case, 3 and the complement will be 3, but 3 already exists. I mean, you can't count the same thing twice, right? So what you do is if it's a 3, you check if the frequency of 3 in this is greater than 1. I mean, if it's 2 or 3 or 4, something like that. And you have to make sure you don't count the same thing multiple times. So you can use a map for that. That's an easy thing. I'll probably discuss the four-sum question. Four-sum is basically the same thing. Binary search, yeah, you can. You can use binary search. Just make sure the indices are different. When you get a binary search result, you can just make sure that the indices are different. That's it. It's the same thing. It'll be the same complexity because map also uses a log n. So whenever you insert an element in the map, it takes log n time. So binary search also takes log n time. So it'll be the same thing. I mean, a sorted map, okay? Yeah, an ordered map will take constant time. I mean, ordered map will take log n time. Unordered map will take constant time. And you can use an unordered map in this case. But I don't think so. A log n factor will make much of a difference in your coding test. As for the interview, I would suggest you to use the binary search method. That is much more elegant solution, and the interview will like it. So for something, same thing. You're given 4 elements now. Okay. And if you save, they add up to the target. So first of all, the simplest brute force solution is what we call as backtracking. Backtracking is basically take one. It'll be an basically take one and then go to the thing and take the next one and then take the next one, and then out of these 3, or it'll be an n raised to 4 operation. You can just brute force all 4 pairs that you get and you'll finally find your thing. Okay, so that'll be an n raised to 4 operation. Now what else we can do is we can store the sums of 2 of them. So we can reduce this to an n square complexity. I don't think so n complexity is possible. We can reduce this to an n square complexity. How? We'll just create a map in this case. Map, or let's say we create a okay. The basic idea in this is to store all the 2 sums and then finally check if 2 sums add to 4. So that way you can store all the 2 sums in n square time and check the 2 sums thing in again n time or n square time, however you like it. It won't matter. Okay, so that will reduce the overall time complexity to n square or n square log n or something like that. Now, another thing that you can do is storing pairs, right? So when you're storing in a map, it's best to store them in pairs. So for example, for int I is equal to 0 till I is less than num, you have to store them in pairs, right? So for now in this case, we have to notice one more thing is the permutation of this doesn't matter. For example, if 0, 0, minus 1, 1 won't count. I mean, it's the same thing as minus 1, 0, 0, 1, right? So okay, so the question is how do we store them? So map int to what? So first thing is for sum at we can map it to a vector. I think that would be a That would be an easy thing. Just map it to a vector of pairs. Yeah, I mean, J should be equal to I plus 1. Okay. So this thing looks like a huge thing. It's not just, it's just a vector of pairs. So in this case, we're going to store all the pairs I comma j as a vector by their sums. Okay. So based on what sum they give, we're going to store them. So this is a vector dot yeah, my mistake, pair of int comma int. Okay. So I'll break this down into 2 steps. Int sum is equal to this, and for sum at this will be a vector, and this vector dot push back this whole thing. And what is this? This is nothing but a pair. So int pair int variable name of map. Oh yeah. Oh, so it can't be for us. Sum for, my mistake. Okay. Sum for. Okay. Pair. Let the pair be equal to I think that's better. Okay, so I pair P, and finally we just have to insert P into this thing. So when we do all these iterations, so basically another thing is these things won't repeat, right? Because we are going through all disjoint I comma j. In other words, I comma j we're going to, but we're not going to j comma I again. So next what we want to do is we take we basically take one value out of this map and check if a complement for that exists. Okay, so how will we do that? We can just use an auto thing, auto x belonging to sum 4. Now what will be x? X will be a pair of int and vector of pair of int. Okay, so it'll be a really complicated thing. So x dot f, sorry, x dot first will give us what? The first value in the sum, right? So int complement will be equal to target minus x dot first. So x dot first is the first value in the sum. I mean, the first 2 values in the sum are this, and the complement will be given by target minus x dot first. Next, what we have to do is we have to go through all the elements again. So we go through all the elements again and check if if y dot first is equal to complement, in that case we have to do something else. Continue. Okay. So another thing, we have to make sure that y dot fx, so these two things don't match. How will we do that? I mean, in here there can be overlaps, right? So to prevent that, what we'll do is use x dot second, the vector. So the vector has to have at least two of those, as in also how are we going to return this? What do we call this? Quadruplets. Finally return quadruplets. Okay. So in this case, quadruplets dot 3, 4. Four things will add in this quadruplets. First thing will be x dot second. X dot second is a vector. So we'll call this things as for example, let's say let's say we have 4 and let's say we have 2 comma 2 and 2 has let's say 1 comma 1 and let's say 2 has 1 comma 1. It can't have anything else. Or have they given 0? Okay, so let's say 2 has 2 comma 0. So what we'll do is uh, this will be a first pair, right? So first first pair will be equal to the first value in this, or should be not do it that way? Can there be multiple values? Yes, they can. We'll have to use a while loop then. Okay, so I think this method will get complicated. Does anyone know a simpler method? Come on, let's call this vec is equal to x dot second. Oh, okay. 1 second. There you go. So I just added this one line. I'm just storing this x dot second in a vector in another variable vec. And just call this auto. too much of too many lines. Okay. Uh, all we have to do is now, if x dot first is equal to complement, we have to basically check if y dot second. First thing is if complement is equal to itself or if it is different from itself. If it's different from itself, you need to search for y. Else, you can just use this itself, right? So if complement is equal to x dot first, in that case, we will have a different code. Else, we will have a different code. So we'll analyze the second case first. Second case will be much easier. All you have to do is find y belonging to some 4 and basically make pairs out of all of these things that we have in y. So if y dot first is equal to complement, then we have to make pairs, right? So let's say the quantity of you can basically select one from y dot second and one from vec and make a pair out of those things and transfer them. So okay, so how can we make pairs? I think we'll have to use the n square thing itself again. Another 2 loops. Have we used I before? We haven't. That's good. Okay. This is gonna get bad. So if I is less than vec dot size, and we'll call this vec 1 and we'll call the other thing vec 2. Now in this case, what you have to do is just push back x dot not x vec 1 at I dot first. Okay, I'll just define them as separate 4 integers. Int a, have we used a before? A is equal to vec dot I dot first. B is equal to vec of I dot second. Okay, so these are our 4 quadruplets. Most likely, this loop will only execute once, even though it's like a double for loop. It won't execute more than once in most cases, or it may execute at most like twice or thrice. It won't. It's not like a double for loop. I think we are testing all four cases, but excluding some because of this. This is the only condition that is preventing us from executing all cases. If complement is equal to x dot first, that basically means that it's like 4 and then you have 2 and 2 plus 2 equals 4, so that type of case. In that case, what we basically do is uh, again we have to do the same thing, but vec2 will be equal to vec1 itself. We'll have to again use a double for loop, and till I is less than vec1 dot size. What does I say second size? Debugging this is going to be a lot of time. J is equal to I plus 1, j is less than vec dot size, j plus plus. Okay, so let's see if it runs. I'll just pause the share and I'll log in. So I better save the code. I don't want to type all of this again. Okay, so we're back and let's try running this. It's gonna give a lot of errors, but let's see. Okay, line 5. I is less than nums dot size. Okay. Have we defined vec2? Oh, it should be vec1 itself. Um, okay, so here also. Whoa, that's a hell lot of things. First thing, let's check if this sum is adding up to 0. Okay, so this sum is adding up to 0. Okay, so we have considered all. So we have to put another condition to just consider the unique ones. So at least in this case, it isn't giving duplicates. I think we'll have to modify this. Okay. Let's try removing these for loops. Okay, so this case is again getting considered twice. Okay, that's better. So this and this are the same thing. So anyone, any ideas on how we can fix this? Why is this happening though? We're considering -2 and -1. Okay, that's giving us 3. Okay, so I think we'll just implement a dump thing wherein we just check that they're unique by brute force. And this, when we find A, B, C, and D, we'll just check if they're unique. Pretty sure there's a more elegant solution. Let's just run the code. Okay, so we are considering duplicates. But how? Mhm. Okay, so I'll probably try to fix my errors on this one and get back. I don't want to waste time, Ryan. We'll just start on another question. Okay, sure, no problem. You can leave if you want. I'll probably post the solution on this on the group. I'll solve this and put the solution on the group. I'll discuss the next greater element thing. That is really important. Okay, so given a circular array, okay. So what the next greater element basically is let's say you have an array like 1, 5, 1, 1, 3, 7, and 10. Okay, so for one, when imagine you're one and you're looking, and think of these as like mountains. That's the best way to imagine this. Think uh, one as like a peak at point distance 1, and 5 at like another peak way higher up. Something like this. 5 will be somewhere here. Then 1 will be again down. This is 0. Okay, we don't start. We start over here. So from 1 you see up, you see 5. From 5 you see up, you see 7 somewhere over here. So from 5 you go down, you get 1 over here. Then from 1 you go back up to 3. From 3 you go back up to 7. And from 7 you go back even further up to 10. So imagine now if you're at 1 and you're looking up, what's the first peak that you see? That is 5, right? Similarly, if you're at 5 and you're looking up, what's the first peak that you see? You will see 3. And imagine you're at 3 and you see up. What's the first peak that you see? You will see 10. Oh, imagine you're at 7. From 5 you'll see 7, and imagine you're at 7. The first peak you see will be 10. Now imagine you're at this point, 1 again, and you look up. The first peak you see will be 3. The first greatest number you'll see will be 3. Similarly, if you're at 3 and you look and you'll see the first greatest as 7. So for 1, the next greatest will be 5. For 5, it will be 10. For 1, it will be 3. For 3, it will be 7. And for 7, it will be 10. Oh, sorry. For 5, it will be 7, not 10. My mistake. For 7, it will be 10. Okay. So the way to calculate this is to use a stack. That's like the most common application of stack. Okay. So you're given, but in this case, the challenging thing is it's a circular array. So if you see 1, for 1, the next greater is 2. For 2, there's nothing in this whole thing which is greater than 2. I mean, equal to is not counted. Okay, so if 2 looks ahead, he sees 1, and then after 1 you can come back here because it's a circular thing, right? So after 1 you come back to 1, then you come back to 2 and you don't see anything, and then you go to 1, and then 1 again has nothing ahead of it, but it can go back to 1. So it goes back to 1 and then it goes to 2. So for 1, the next greater is 2. So the basic way to solve this is nothing but to solve the next greater element. And in this case, since it's a circular array, we'll just count the array twice, one after another. So for example, whenever you're given something that is circular, for example, a circular permutation or some like one guy after another guy. So basically for first person, he can go to the, let's say you have like 5 people. So let's say you have 1, 2, 3, 4, and 5. 5 people are there. Okay. So first person can have all choices. First person can go all the way up till the end. These are all the choices he has for the next greater element. The second guy has all these choices, while the third guy has only these choices, and the fourth guy has just one. Fifth guy doesn't have any choice. But in this case, it's circular. So first guy has all choices. Second guy can go up to here, and then he can come back because it's circular. Third guy can also go up to here and he can come back. And then he can go up to here also by coming back. And similarly for fourth. So this is equivalent of saying we put the 5 people one after another. And then we um, just a second. Okay. So then we just write them again. We write those 5 people again. So in other words, first guy has choice up to this guy. Second guy has choice up to this guy. Third guy has choice up to this guy, which is the third guy again. Fourth guy has choice up to this guy, and fifth guy has choice up to him. So that's the basic thing for solving circular things. Length won't increase 10,000. So that means you have to use a linear solution. You can't use a quadratic. For this, the quadratic was take each element and then go to the array and find its next greater. The basic brute force approach. So upper bound, yeah, you can. No, wait, for upper bound, it has to be sorted. That's the main thing, right? So in this case, it's not sorted. So you can't use upper bound. N is equal to nums.size. Then what we have basically have to do is go through all of them, and for each one you find the next greater one. So how will we maintain the thing? For that we use something called as a stack. So initially what we'll do is we'll push the first element to the stack. So stack dot push. So stack has push while a vector has push back. So keep that in mind. Stack dot push nums at 0. So we'll push the first element to the stack. How this will work is, I'll just draw it out and show you. So what we'll do is we'll push this element to the stack. Next we'll go to this element and we'll see, is this guy bigger than the first guy? If he is not, if he is, then we found our answer for the first guy. So for the first guy, we can just say pop the first guy from the stack and assign the bigger guy for the first guy as this guy over here. But let's say he's not the bigger. Let's say he's equal to this guy or maybe smaller than this guy. We move to the next guy and we push this also to our stack. So we push this guy to our stack and this guy to our stack right now. And we move to this guy. Okay, so I'll give a number example, that'll be better. 1 7 3 7 1 7 3 1 5 8. So the thing to note is if no one, if let's say this guy 8, right? So he doesn't have anyone in this array bigger than him. In other words, the largest element won't have something bigger than it. In that case, he will store -1. So that is the base case. So 7, does he have a greater guy at position 3? He doesn't. So put 7 to the stack. Sorry, first thing is push 7 to the stack. So our stack S is like this, where the stack is what? It's like structure like this, right? 7 is over here, pushed inside. Next, check 3. Is 3 greater than 7? So is 3 greater than 7? No. Is 3 greater than the top of the stack, which is this? Well, 3 is not. So push 3 also to the stack. What about 1? Is 1 greater than the top of the stack, which is 3? I mean, if 1 is not greater than 3, it obviously won't be greater than 7. So we don't have to compare it with 7 at all. So if it's not greater than 3, push 1 to the stack. Next, check 5. Is 5 greater than 1? Oh yes, it is greater than 1. So I mean, is 5 greater than the top of the stack? So yes, 5 is greater than the top of the stack. Remove 1 from the stack. Assign 1 the value of 5. Now check 3. Is 5 greater than 3? It is. So assign 3 the value of 5 and remove 3 from the stack. Next, come to 7. Next, come to 7. Is 5 greater than 7? No, it's not. So push 5 to the stack. Next, come to 8. Is 8 greater than 5? Yeah. So 5 points to 8. Remove 5 from here. Is 8 greater than 7? Yes. So 8 points to 7. 7 points to 8. Sorry. Remove 7 from the stack. Now the stack is empty. So what we do in that case is we put 8 to the stack. So let 8 be the first element in the stack. So if the stack is empty, push 8 to the stack. Next, we don't have any more elements, right? So what we basically do is now whatever at the end of this is remaining in our stack. So in that case, only 8 is remaining in our stack. We assign that a value of -1. So 8 takes a value of -1. So if there was one more 8 after this, for example, in that case, is 8 greater than 8? No, it's not. To push that to the stack. Greater, okay, it can't be equal to greater. So if 8 is not greater than 8, push 8 to the stack. Then finally, our stack still has some values, right? So these values haven't been assigned a next greater because they don't have one. So in that case, we can just say that the next greater for them is -1. Okay. So, but in our case, what we have is we can traverse the array in a cyclic manner. So for 8, we can come and check 7, 3, 1, and 5 also. It can be that they can have one. So let's say there was like something like 16 over here. Then for 8, the next greater would be 16, right? If cyclic was allowed. So in that case, what we want to do is we want to reproduce the same array over here. So 3, 1, 3, 7, 7, 3, 1, 5, 8, 8. And if 16 was over here, let's say 16 was between over here, somewhere 16 was there. So for 8, the next greater would be 16. And that way we just keep going till here. We search till here. But we add elements only up to here. That's the basic thing. So first we'll solve the basic next greater element, and then we'll do for the cyclic case. So stack.push nums of 0. If I is greater than, if nums of I. So another thing is we'll store the indices because we don't want to store the values. Storing indices is much more flexible and much more valuable. So we'll store the indices. So if nums of I is greater than, so first thing we'll check is if stack is empty. If stack dot empty, if stack dot empty is true, in that case stack, sorry, not stack, S, right? So our stack is called S. So S dot push I, because indice is always not the values, and continue. Next, if nums of I, as in the value at this, is greater than stack dot top. In that case, what do we have to do? In that case, stack dot pop. So wait, in that case, so wait, one more thing that we need is the final array that we have to return. We'll call that as a answer vector answer. Yeah, I'll correct that. Just give me a second. So if nums of I is greater than nums of S dot top, in that case, that means we have found a greater value for this element. Okay. So in other words, answer at S dot top is equal to, again, S dot top is an index. So we'll have to again initialize our answer array, answer vector with some size, n size. So if we don't initialize, that means it has size 0. In that case, we can only use the pushback function. We can't use this function because it won't have any values in it, right? So it won't have size basically. So answer at S dot top will be equal to, we'll store the index, right? Or they want us to store the value. I think they want us to store the value. So we'll store the value. Nums at I. And S dot pop. S dot pop because, as we had seen, moment we find that a greater element exists, we can remove it from our array. Like how we remove this, then this, somewhat like that. So S dot pop takes it off. Now what do we have to check is the next one. Is there an element inside? Because what we had done, remember what we had done over here. Once we checked with 1, we checked if there are more. Like for example, when we encountered 5, we saw the 5 is greater than 1, 5 is greater than 3 also. So we have to check it until we find that some element is there which is less than it. Okay, so this won't be an if, this will be a while. So while nums at I is greater than nums at top. So S dot top will keep varying because we are doing S dot pop, right? And we have to also make sure that S is not empty. So S is not empty. So this is not, and this is empty. And so S is not empty, and S dot top has found its next greater element. In that case, we assign S dot top answer as an assign S dot top the next greater element and S dot pop. And after all of this, while our stack is not empty, we have to assign the others as -1, right? So while S dot empty, so while stack is not empty, answer at S dot top should be equal to -1. And finally, what do we have to do? We have to push this element, right? So for I is less than n, we have to push this because we haven't found a next greater for a current element. We have found for that the current element is the next greater for all the previous ones, but we haven't found a next greater for a current element. So this thing will be outside. So this thing will be outside. And okay. So if you see, this function is not required because if S dot empty is true, then this will be false, this won't run, and S dot push will be called directly. So we don't need this. This will be called by default. So this is not required. Yeah. So the while should be at the end. Now this won't work because here it's a cyclic array, but this thing should work for a normal next creator element. So for a cyclic one, what change do we make? The only change we have to make is we have to check with the values from 1 to 2n, but we only need the next creator element for the first n values. So our answer will only store for the first n values, but we will check for the first 2n values. So what we can do is say nums is a vector, right? So nums is equal to this is basically creating a duplicate of the same array at the end of it. You could use this, or you could use also the modulo operator and check if it goes above n. You could do a modulo and get it back. I think that will be better. So uh, so wherever I is there, I will replace it by I modulo n plus 1, not n. Why not n? Because if it's I modulo, no wait, it will be I modulo n. So if the value is n, we will get to the index 0. No, top shouldn't be modulo, I think, because top, we are pushing back this, right? I modulo n itself. Okay, no. Yeah. Don't push back I, just push back I and okay, so let's see. This is bound to give us an error. We have to take care of an edge case over here. We'll do that in a while. Oh, okay. Okay, brackets again. These are all functions. But here we're going to get an error because this is going to cause a mess. So we'll fix that. Okay, time limit error. This is running an infinite while loop. Oh no, we aren't popping over here. Okay, so that's the thing that's happening over here. So when you're printing answer at top modulo n is equal to -1, that basically means we are returning it back to the same stage as the non-cyclic stage. So to handle that, what we need to do is if s dot top is greater than n, greater than equal to n, well, then we continue. Oh, only if it's less than n. Okay. So there you go. So what we have basically done here is instead of duplicating the array and counting it as like the way I had shown in the on the whiteboard, what we can basically do is use modulo operator. So we run from index 1 all the way to index. So like 1 to this and then this thing again. So we go from here 1 to 2 to 1. And then we come back to 1 and then we go back to 2 and then back to 1. So something like this. So for 1, the greatest will be from 1 to 1, 1 to 1. So out of those, the greatest it found itself. So it found 2. So it's done. As for 2, it has to choose the greatest from this one, as in all the numbers other than itself in the array. So that is handled by this. So where are we using the modulo? First thing is, we are storing the numbers in the stack by their default name, because if we store them by their modulo name, in that case it will become an infinite loop. I mean, it won't be of any use. It won't be an infinite loop. It just won't be of any use. And in this case, if s dot top is less than n, if it's greater than n, then chances are it will have a -1, right? So what we are doing when we go to 1 and then 2 and then 1, and then again we go to 1, and then again when we go to this 2 and again when we go to this 1, the second time we go to this 1, it won't have another thing after it. So in that case, it will store a -1. So when we take a modulo with it, we will return back to the first one, first time we encounter this one, and that will store that as -1, but we don't want to do that. So only if the s dot top is less than n, we are storing its value as -1 if it doesn't have an x greater element. And that's pretty much it. It's a simple question and a really common one too. So that's how we solve it. I think that's it for today.